At school we learn to balance equations using the trial and error method. This method is the easiest to learn, but it soon causes frustration if an equation has a difficult-to-guess coefficient. Take the unbalanced equation on the screen. This describes the complete combustion of hexane. You could balance this by adjusting the numbers that go in the gaps until the equation is balanced. But I doubt that you would find it easy. The solution is as follows. 2 lots of hexane react with 19 oxygen molecules to form 12 carbon dioxide molecules and 14 water molecules. To prove that it's balanced, we count the number of carbon atoms. 12 on one side and 12 on the other. Balanced. Then the number of hydrogen atoms, 28 on one side and 28 on the other. Balanced. Finally the number of oxygen atoms. 38 on one side and 24 plus 14 on the other. So the oxygens are balanced. This equation probably seems quite tricky to balance. Thankfully there is a way to take all the guesswork out of equations. Just use algebra. Essentially we put the algebraic symbols x, y and z in front of each molecule in the equation. These symbols represent the unknown numbers that we are trying to find. For the example of hydrogen reacting with oxygen, we have X hydrogen molecules, and Y oxygen molecules react to produce Z water molecules. It is possible to find the values of X, Y and Z using intelligent trial and error. But there is a better way. We write down simultaneous equations by counting the number of atoms of each element on each side of the equation. For example, we have 2 X hydrogen atoms on the left-hand side, and 2 Z hydrogen atoms on the right. We also have 2 Y oxygen atoms on the left-hand side, and Z oxygen atoms on the right. Simplifying gives us our equations, X equals Z, and 2Y equals Z. Step 3 is to solve the simultaneous equations. Just like you were in maths class. In general, chemical equations have an infinite number of solutions, but they are just multiples of each other. This corresponds to the fact that you can multiply both sides of the chemical equation by the same number, and the equation will remain balanced. If you have to choose which solution to give, then choose the lowest whole number solution. For our case we have x equals 2, y equals 1 and z equals 2, rather than any multiple of that solution. In an exam question where you are given one or more of the coefficients, then things are simpler as there can only be one solution for you to find. Schools do not generally teach this method as some students struggle with algebra. But it is good to know the algebraic method as it allows you to balance any chemical equation. I would recommend you reserve this method as a backup for the most difficult problems. Now we will try to balance a really tricky equation. The combustion of octane. First we put algebraic symbols W, X, Y and Z into the equation. We need 4 symbols this time as there are 4 unknowns. Next we write down the simultaneous equations. On the left-hand side we have 8 W carbon atoms, and on the right we have Y carbon atoms. On the left-hand side we have 18 W hydrogen atoms, and on the right 2 Z hydrogen atoms. On the left-hand side we have 2 X oxygen atoms, and on the right we have 2 Y plus Z oxygen atoms. Once we have simplified the equations we have 8W equals Y, 9W equals Z, and 2X equals 2Y plus Z. We have 4 unknowns and only 3 equations, which is normally not enough to find solutions. However, we have the freedom to take one of the coefficients and set it to any number we want. This is because there are an infinite number of solutions, all multiples of each other, which means there is a solution corresponding to the value we have chosen. I will choose to take W equals 1, as this seems convenient. This gives us Y equals 8, Z equals 9, and X equals 12.5. Unfortunately, the value of W I picked did not correspond to a whole number solution. But this is no problem because we can simply multiply all the coefficients by 2 to get a whole number solution. Our balanced equation has 2 molecules of octane reacting with 25 molecules of oxygen to produce 16 molecules of carbon dioxide and 18 molecules of water. Imagine trying to get that with trial and error. If you would like to test your understanding, why not try balancing a few equations that you are already familiar with? You can also try to balance the equations on the screen or even the equation that this video starts with. These are very similar to the worked example, so you can use that as guidance. The algebraic technique goes slightly beyond what is taught in schools, but it should reassure students that they have an ace up their sleeve, as other students will definitely not know it. I hope you found this video helpful. Like and subscribe for more science questions and tutorials from Science Hop.